Good morning, you guys. So today we're going to be talking about directional derivatives and gradient vectors. So what is the directional derivative? Well, we'll be finding the gradient of a function. So you'll be given a function f(x, y, z), and you'll be asked to find the gradient of it. The gradient is the derivative of the function with respect to each individual variable. So in this particular example, you will have the function f(x,z,y), and you will take the derivative with respect to using dabba f, dabba x first. Then you evaluate it at your point that'll be given in your problem. Then you do the same for y. You'll find your dabba f, dabba y, and evaluate it at its point as well, and do the same for z. Moving along, with what we will use the gradients for will be to find the equation of the tangent plane, the equation of the normal line, and the equation of the line tangent to the intersection of two planes. So first off, to find the equation of a tangent plane, you will be given a point and you will be asked to find the vector to that point, and you will take the dot product of that vector and the gradient of f evaluated at p naught. For the equation of the normal line, you will be given the gradient, you will be given a function of which you will have to find the gradient of and a point. With those, you will have to find this, which can be, some would say is r naught, but is just the vector from the origin to the point that you're given. You will find of the function, you will take the gradient of the function evaluated at p naught, and then you will use the equation of the line formula essentially. So you'll be multiplying the gradient of the function at p naught times t, and you'll be adding the two vectors. Now sometimes you'll be asked to find the parametric equations, and that's relatively simple. You're just taking the point t's, you're just taking the x's, the equations of the x's, the y's, and the z's. For the equation of the line tangent to the intersection of two planes, you will be given two functions, the function of f and the function of g, and you have to find the gradient of both of those functions, evaluate them at the point you're given, and take the cross product of the two. Once you take the cross product of the two, you will put it into the equation of the line formula, where you will be adding it to the r naught vector, is what I like to call it. And once you add it to the r naught vector, you'll multiply the cross product of the gradients times t. And with this particular problem, you might be asked to find the parametric equations as well. So you will have to find the equations of the line for the x values, y values, and z values. Thanks for watching this video. Hope it helped.